Hi, our next topic is rational number and their decimal expansions. So, for example, take 0.375. This is a decimal expansion. To express it in p by q form, what we can do is, if you remove this decimal, you get 375 by 1000. Now this is equal to 375 by 10 cube. This is this is a p by q form of 0.375. Now, if you want to simplifying, we get take express 375 in prime factorization. You get 3, 1, 2, 5, 5, 25, 5, 5. So 375 by 10 cube is equal to 3 into 5 cube by 10 cube can be written as 2 cube into 5 cube. You can cancel 5 cube and 5 cube. This is equal to 3 by 2 cube, which is equal to 3 by 8. So this is a simplified form of p by q. Next, 3 by 8. So what you here is equal to 3 by 2 cube. Let's see one more example. One more example is 0.0875. This can be written as 875 by 4 zeros, 1000. And if you prime factorize 875, you get 5, 5 ones are 5, 37, 5 sevens are 35, 5, 5 threes are 15, 5 fives are 25, 5 7 this, so it is equal to 5 cube into 7 by 2 power 4 into 5 power 4, which is equal to 7 by, you can cancel 2 power 4 into 5. This is a simplified form of 0.0875 expressed in p by q form. So what you can observe here is, here 3 by 2 cube. If if denominator is of the form 2 power m into 5 power n, where m and n are positive integers, then this will be a terminating rational number. Terminating number. If it is not of the form, if denominator is not of the form 2 power m into 5 power n, then rational number decimal number will be non-terminating and recurring. Let's see the theorem. First theorem 1. Let x be a natural number whose decimal terminates. Then x can be expressed of the form p by q, where p comma q are co-prime and the prime factorization of q is of the form 2 power n into 5 power n and m are non-negative integers. So if denominator can be expressed of the form 2 power m into 5 power n, then the rational number will be terminating decimal number. Next, let us see theorem 1.4. Let x equal to p by q be the rational number such that prime factorization of q is of the form 2 power n into 5 power n, where n and m are non-negative, then x is a decimal expansion. X has a decimal expansion which terminates. That is, if denominator can be expressed of the form 2 power n into 5 power n, then this rational number will have the terminating decimal expansion. The decimal expansion of that rational number will terminate. Next is non-terminating recurring decimals in rational numbers. If it is not of the form 2, denominator is not of the form 2 power n into 5 power n, then the decimal expansion of the rational number will be non-terminating and recurring. That's all. Fifth example. Using the above theorem without actual division, state whether the decimal form of the following rational numbers are terminating or non-terminating repeating decimals. First one is 16 by 125. Here denominator is 125. Let's do prime factorization. 5, 25 is 5, 5 is so 125 is equal to 5 cube. This is of the form 2 power m into 5 power n, where m is equal to 0 and n is equal to 3. Therefore, this is terminating. Second one, 100 by 81. Let's do prime factorization for 81. 3 1 are 327, 3 9s, 3 3. So 81 is equal to 3 power 4. This is not of the form 2 power n into 5 power n. So this is non-terminating recurring. Non-terminating recurring. Next, example 6. Write the decimal form of the following rational number without actual division. 35 by 50. Let's do prime factorization for 50. 5 ones are 5 times are 5 ones are 5 2 so 200. So 50 is equal to 2 into 5 square. What you can do is 35 by 50, you can write it as 35 by 2 into 5 square. Since you have to express this in the other form 10 power n, you can multiply it with 2 in numerator and denominator. So it will be equal to 35 into 2 by 2 square into 5 square, which is equal to 70 by 2 square into 5 square is 10 square, which is equal to 70 by 100. So this is equal to 0.7. Next is 7 by 8. 7 by 8, you can write it as 7 by 2 cube. What you can do is you can multiply numerator and denominator with 5 cube. So which is equal to 7 into 125 by 10 cube, which will be equal to 875 by 1000. This can be written as 0.875. Next is exercise 1.3. First bit, first one. Write the following rational numbers in their decimal form and also state whether they are terminating and which are non-terminating repeating. So first one is 3 by 8. 3 by 8 can be written as 3 by 2 cube. Now multiply numerator and denominator with 5 cube, which will be equal to 3 into 5 cube is 125 by 10 cube. 3 into 125 is 375 by 1000, which is equal to 0.375. Since the numerator is of the form 2 power n into 5 power m, this can be expressed as this decimal expansion will be terminating. Second one, 2 by 11. 11 is a prime number and denominator is not of the form 2 power n into 5 power n. So this is non-terminating recurring, non-terminating and recurring. That's all second bit. Without performing division, state whether the following rational numbers will have a terminating decimal form or non-terminating repeating decimal form. So first one, 13 by 3125. Now let's do prime factorization for denominator. 3125. 5 6 are 30, 5 2 are 10, 5 5 are 5 are 1 25, 5 are 25, 5 5. So 13 by 3125 is equal to 13 by 5 power 5. You can multiply numerator and denominator with 2 power 5. You don't need to multiply. You are not finding a decimal form. You have to find out whether if decimal expansion is terminating or non-terminating. Since denominator is of the form 2 power m into 5 power n, where m is equal to 0 and n is equal to 5, this is terminating. Decimal expansion will be terminating. So one more question. Second one, 129 by 2 square 5 power 7 7 power 5. Here if you observe, you have 2 square 5 power 7 into 7 power 5. Since you have 7 in the denominator, this is not of the form 2 power m into 5 power n. Therefore this is non-terminating. Non-terminating. Next bit is third one. Third bit. Write the following rational numbers in decimal form using theorem 1.4. 13 by 25. So you can write 13 by 5 square. You can multiply 2 square and 2 square. It will become 13 into 4 by 10 square, which is equal to 13 4 is 52 by 100. So this will be 0.52. Next bit is second one. 7218 by 3 square into 5 square. Since you have 3 square here, what you can do is 3 square into 5 square is 9 into 25, which is 225. Now let's do division. 7218 into 225. 225 into 3 is 75, 675, 3, 6, 11 minus 7 is 4, 46, 468, 25 2s are 450. So 18. You put a point, you get 180. You put a 0, you get 1800. 1800 into 8. 225 into 8 is 8 5s are 40. 8 2s are 16. 16 plus 4 is 20. 8 2s are 16. 16 plus 2 is 18. 1800. So 0 is remainder. Therefore 7218 by 3 square into 5 square is 32.08. That's all. Fourth question. Express the following decimal form in P by Q and write the prime factors of Q. What do you observe? This is 43.123. This can be written as 42.123. Can be written as 43.123 by 1000. Here in this question 43.123, here it is terminating, so this is rational. Second question 0.120, 1200, 1200, 12 zeros. So this is not terminating, so not terminating. Third one 43.12 bar. This is non-terminating but recurring. So this is rational. It can be expressed in the form of P by Q. That's it.